if you feel like what's on the screen is a lot, it's because in this unit, matrices, you're going to learn all this stuff. For today, we're not going to learn all of that stuff. Basically, we're going to do these two, which is kind of like learning to add them, subtract them, and take systems of equations and set them into matrices. And it seems really hard. It's actually super easy. I can look at this lesson and go, oh, I'm so glad we have an easy day. All right. So this is a typical matrix right there, okay? And you describe them as having rows and columns. The rows go this way, and columns go this way. It's kind of like columns hold up buildings. So do you see that this has 2 red rows, and it would have 3 green columns? And you always do the rows first by the columns. It's not actually multiplying, it's just this by this. And so that is 2 rows by 3 columns. So that's called a 2 by 3 matrix, okay? If you really understood that, then I should be able to make you a matrix 2, 1, 5, 3, 4, 7, 1, 1, 1, 2, 8, negative 1. Now that's a matrix. Doesn't have to have the bars around it. Ideally it does, but my question is, that's a what by what? It's definitely not a 3 by 3 because it's not square. All right. Would you talk to the kid next to you? That's a what by what matrix. It's got, these are rows, 1, 2, 3, 4. So 4 by, there's 3 columns, 4 by 3. Are you with me so far? Do you get if it had been a 3 by 3, it would be square, like 3 across, 3 up and down, all right? Okay, cool. Then here's a sheet that summarizes this in a much prettier way. The rows are like the yellow, the columns are like the green, and this one would have 2 rows and 3 columns, so it's a 2 by 3. Notice you always do the rows first. That's important. Because if I say it's a 3 by 4, you got to know which of those is rows. And it's always RC, like remote control. RC, rows, columns. Okay, on to this one. So, what's this one? One, 2, 3, 4 by 3. Who had 4 by 3? Okay, I think you're getting this. Is this a square matrix or not? It would have to be like 4 by 4. Is it a 4 by 4? Is it a 2 by 2? No. Is it a 3 by 3? No. So it's not square. Is this one square? Kind of looks squarish, but is it? Well, it's a 1, 2, 3 by 1, 2. 3 by 2 is not square. All right. Moving on. Within the matrix, this is a really complicated way of describing exactly where you are in the matrix. So if you say A3, 3, that means you are in row 3, column 3. The first number is the row, the second number is the column. A is just the name of the matrix. So if I had a bunch of matrices sitting around, like here's matrix A, and here's matrix B, and this is 1, 1, 4, 7. You do not have to copy these. And that was -1, -1, 2, 8. And I wanted to say, hey, I want A2, 2. It's not, doesn't take you too long to figure out, well, it's in the A matrix. And what's the 2? It's row 2. Because remember, always the first one's row, second one's column. Okay? So, which one of these is that? Talk to the kid next to you. What's A2, 2? What's in the A matrix? And it's row 2. 1, 2, column 2. 1, 2. Oh, it's that one. It's 7. That's correct. Okay. All right. So if I said A1, 2, can you tell me what that is? What's A1, 2? Well, it's row 1, column 2, This is row 1. This is column 2, so it's 12. Raise your hand if you had 12. Cool. Then just one last check on that. What's B21? Remember, it's always rows, then columns. So I really said row 2, column 1. Here's row 2. Here's column 1. It's an 8. Okay, cool. Next thing. If you wanted to add these, it is as easy as you would think. This gets added to this. Because it's the first one, it's row 1, column 1. And the other one is the corresponding row 1, column 1. And so the answer would start with a 7. Then you'd add the 2 and the 8, and that's going to make it 10. We don't put commas inside matrices, by the way. You just leave a space. What's the third number? Cameron?
7.
Yep. You take this, and you just put them together. Subtracting them, just as same idea. This 1 would subtract this 3. And what is 1 minus 3? It's negative 2. And that's the beginning of my answer. And the answers, if they're all add and subtract problems, if this has to be the same size as this. They don't have to both be square, but they have to be the same size. So this is 2 rows. Let's make a darker color here. 2 rows by 3 columns. And so is this. And they have to be the same as each other. And then the answer has to be a 2 by 3. By the way, when you're multiplying, they can be different sizes. But if you're adding or subtracting, they're all going to be the same size. All right, 1 minus 3 is negative 2. Would you please tell me what goes in this last corner spot right there? Which, by the way, the official name for that, I'd have to know what the matrix is. Is it like matrix M? I don't know. So I'm not going to give the official name. I just want the one in the lower right-hand corner. Hanson, what do you say?
0.
0. Because you probably took 7 minus this 7, and you got 0. Okay, adding and subtracting them, super easy. Then we do scalar multiply, and as easy as you would think, you just take a 3 and you multiply it by everything. See this 3? It's kind of like distributing. Everything gets multiplied by 3. Okay, so 7 times 3 is 21. 3 times 0 is 0. 3 times 2 is 6. 3 times negative 4 is negative 12. And there is my answer. Okay, and then this kind, again, as easy as you would think, it's this times this. And then you'd add this times this. So negative 1.5 plus 4 times 0 is 0. So this part's 0, and this part's negative 1.5. And that would go in the upper left corner in row 1, column 1. And that'd be negative 1.5. Would you just do this one, the one I just circled in red, and put it here? Remember that when you multiply by 1.5, by 10, you just move the decimal over. You should not need a calculator. You can get one later if you really need one, but 10 times 1.5 is just 15. So this is really negative 15. And this part here is really negative 12. And when you add them together, you put negative 15 with negative 12. You get negative 27, I think. Who had negative 27? Okay, good. All right. So that is all your add, subtract, multiply by scalars. And by the way, you never divide. Cameron, what was that last answer again?
Negative 27.
Very good. Okay. And I'm not finishing it, but these two would have been easy, so let's move on. This looks super intense, but honestly, it's an amazing way to solve systems of equations. Can you imagine if I just said solve this system of equations? You have to solve for x and y and z. Like, that is intense. First, you'd have to it would take you a long time of substituting or eliminating before you finally figure out all three of them. But if you make it into a matrix like this, then you can type it into your calculator, hit enter, and it'll solve it. That's a pretty cool system. Now, how do you type this in? Well, look, it's just 2 from here goes there. The 3 from here goes there. The -1 on the z, right? That is a -1 there, right? Goes there. And the 6 goes there. See how that worked? And -1, -1, -1. Ooh, look at that. And then the 9 was there. So it's really pretty easy to take the numbers. It's basically get these all lined up so their x's are first, their y's are next, and their z's are last, and that the answer's over here. So you can take any equation, even if it's got 3 variables like that, and you can line it up. So it goes x, then y, then z, then the answer. And then once you've done that, you can pull off the numbers. And then once you've done that, you can tell the calculator to solve it. Now, we're not going to do all of that today. For today, all we're going to ask you to do is take your equations like this, make sure they're lined up so that all the x's are first, all the y's are next, and then you're going to put the numbers in like that. And then we'll show you on another day what to do with the calculator to actually solve it. Okay. All right. So one of the keys is, what if when something doesn't have an x? What if this equation didn't have an x? There wasn't an x. Well, then you'd put in a 0 for that, because it would be 0 x's. Okay? All right, so that's the only trick one. All right, so now can you do it? Well, make a matrix. It's got to have spots for 1, 2, 3 numbers. And it would be 22 to start with. See if you can just finish this matrix. Should be pretty easy. Claire, what'd you get for this top one? 22 and then 1.
Yeah, and then 232.
Correct. And the next one, the next row?
12.
Isn't that a 15?
Oh, sorry, 15.
Okay, and then,
And then 10.
and then,
And then 207.
that's it. And again, once we show you the special thing to do with it, type it in the calc, you do the special thing, poof, it gives an answer, and your answer tells you what x and y are, like this. So if the answer to this came out to 2, 1, it's telling you, oh, the answers are x is 2 and y is 1. You just have to know what that special thing is that you hit in the calculator that takes this and solves it. All right. So this one, I'll just do a speed version of it. I need 3 numbers, 1, 2, 3 numbers, and then the answer. So I need 1, -1, 1, and then the answer is 10. For this row, I would do a 3, a 1, a 2, and then the answer, 34. And last but not least, -5, 2, -1, and that came from here, here, and here, and then -14 at the end, right there. Do the special thing, answer pumps out, and there's how many variables in this? There's 3, x, y, and z. So it would give you an answer like this, 2, 1, 0. Like x is 2, y is 1, z is 0. All right, not saying that's the actual answer, it just looks like that. All right, cool. So, I think that's enough. I think you've got the idea. Except, let's just go backwards. It's like Jeopardy. If the answer was this, then what did it mean? It meant 1x plus 3y plus 0z equals 4. Do you get how I got that? And this would be 0 x's, but you could just like not write it because 0x means 0, plus 2y minus 1z equals 5. And last but not least, 3x plus 0y plus 1z equals negative 2. So you can take a matrix and know what they meant for the equations for it. All right. So, these short units are good news and bad news. This is another short unit. It's not going to be like over on Friday or anything that crazy, but it's short like the last one. And then we have the cumulative. This, as always, we'll have 2 days to review for it, pull it all together. And for some of you, the biggest challenge is, like, most of you were fine in this last test. There was lots of A's and B's. But there's also a decent number of C's where you got both of the graphs wrong. I think the biggest problem, if I were to sum it up, is that people usually had trouble making the graph. A person who had the graph perfect, I can't think of a single person who had the graph right and then didn't answer the question about it right. Like if you got the graph right, it was easy. So the hard part for a lot of people was making the graph. So for some of you, you need a little review of that. And then the best day to do that, I think, is today, because I'm going to hand it back to you. And this is the time to like figure it out. Now, because these are hard to do without the actual questions, I have made a corrections sheet. But the catch is you can only use this in the room. Okay, you can't take this home with you. There are people that have not taken this test yet. Do you get that I don't want all the questions out there while there's people that haven't taken the test yet? So I've got a correction sheet, so it's got graph paper on it and everything, but you need to do your corrections in the room. So if you get stuck, please ask the kid next to you, even if they have a different version of the test. They probably, if they did their problem right, they probably can show you, especially if it's about the graph, some strategies for doing the graph. So I also want to just talk strategy on the graphing part. For most kids, they had the right equations. It's not that you didn't have the right equations. It's you had the right equations and you were like, how do I number this thing so that it looks right? And if you didn't start with the numbering, then you can't possibly make the graph good. All right, so if you're going to number it, each box has to be something, right? And I'd say that the kids who did this the best had a consistent and, like, I think I might be biased here, but I would count by, like, something that ends in 0, okay? Like 10s for each box or maybe 20s for each box. Okay, if you can count by like 15s, but it's a pain in the butt. So I would just check and see if counting by 10s would possibly work. And if you're like, nope, that's not going to work, count by 20s or maybe 30s, but that's kind of a weird number to count by. 10s are easy to count by, 20s are easy to count by. The next thing I might jump to would be 50s. Each box is 50. And there was a fair number of kids that did that. Okay, so it's like 50, 100, 150, 200. So count by 10s or 20s or 50s. All right. From there, of course, start with your y-intercept, and then your slope does the rise-run thing. And almost everybody knew that there was a slope involved. I think it's because you just didn't get this set up right for what to count by. And I think it's safe to say that the questions we had, counting by 50s would have worked, but it makes kind of a smallish graph, because you only go over like 3 or 4 spots. But counting by 40s also is possible. Just don't count by 30s, that's too weird. I would personally probably go with 50s or maybe 40s. Maybe 20s. If you might have to, I think the kids that counted by 20 had to extend the graph a little bit. Because if you count by 20s, you have to do a lot of 20s. Okay, so if you get your test back and you don't like it, you can do the corrections for it. Now, there will be a few kids that'll get a B and they'll just be like, it's not worth it. Don't feel like dealing with it. I have a straight A in this class and I'm not worried about just leaving a B in my grade. And I'm going to leave it alone. And I respect that decision. I know you have a lot of things coming down. You might have a huge, AP test coming and you just don't want to deal with this. So it's fine. I would strongly recommend anybody with a 75 do corrections, because the 75 in the grade, that definitely hurts your grade. And you want a chance on the cumulative, if you do better, to raise it. Remember, that's why you do corrections. It's because you want to understand this better, so that when you take the cumulative, that it can count. If you don't do the corrections, the cumulative can't count as a retake. All right, so that's enough for today. Actually, I decided to start the Schoology quiz with you. So, reading that first question to me. Lucy, could you read me the first question?
It says find C.
Find C. All right. So, it must be telling you something about a matrix, right? What does C look like, or what are you supposed to do?
There's a -3 multiplying the first bracket.
Okay, there's a -3. Oh, wait, let me change this to, pen is off. There we go. -3, and then there's a bracket like this.
Yeah.
And then what?
And then the top left is 4,
And then let's read from left to right.
-5, 2.
Keeps going. Of course it does.
Or, like, the bottom.
Oh, now it's going to 2,
Yeah.
and then?
1.
Awesome. And what am I supposed to do with this?
And then it's like the same bracket with A, B, C, D.
Ah, so they just want you to say that the answer for the first part is A, and then B, and then C, and then D. Got it. Okay, and now what do they actually want me to find and type in? All of them?
C.
Just C. Cool. All right, thank you for explaining all that. You'd take that, and if I really just want this lower left-hand corner, then you take that times that, and I hope you know that the answer is -6. Raise your hand if you had -6. Okay, awesome. All right, I just wanted to get started. I think that this is a fairly easy Schoology quiz. Remember, the kid right next to you has the same questions, and it would be a good resource if you need help. And that's now I'm really actually going to end the video. That's all I got for today.